Hello all, welcome to Smart Civil Engineer. In this session, we'll discuss about the analysis and detailing of a simply supported beam with point load condition by using the Staad.Pro Connect Edition. For that, first we'll open that Staad.Pro Connect Edition. So here, go to File, click on this New, then select this model info. Then in this model information have to enter the file name as simply supported beam with point load. So here, and the next one is location. Wherever you want to save this file, then select that location in your PC. And now the type of structure is analytical type, and the units is I'm changing that from English to metric, and then click on the create. Now the Staad.Pro window will be open. This is a working area, and these are the menu bars. Already the GUI of Staad.Pro Connect Edition is explained in the previous sessions. Now here we know already these are the analytical modeling steps, means working steps. In the working steps, the first one is the geometry, properties, materials, specifications, supports, loading, analysis, and the design. So these all are the working steps in this Staad.Pro, and these are the workflow sheets. Now coming to the simply supported beam with point load. So how to create a structure by using this Staad.Pro Connect Edition means, here first coming to the analytical modeling in geometry part. What is the use of this geometry part means, in this you have to create the structure. Means just draw a simply supported beam with end parts. Now for that, go to select, then select the node cursor. Then here have to see the right side of the screen. There is three coordinates: x coordinate, y coordinate, and z coordinate. So the beams are in x and z coordinate, and the columns are in y coordinate. So if in case if you have to draw a space structure, then draw the beams along the x and z lines, and the columns are in y direction. If in case if you have to draw a, or if you have to design a normal plane frame, then give the dimensions in x direction only. So here I'm selecting the node cursor. Then here I'm creating the simply supported beam of 10 meters length, and the point load is at the center. That point load is also 10 kilonewton acting at the center of the beam. Now the first point of that simply supported beam is 0. Enter the 0 in x coordinate place. Now here you can check the units. All the units are in terms of meters. Then click on enter. Automatically on the working area, one node point will be created. That is our first point of a simply supported beam. Now coming to the second one, my distance of the I said the distance between the simply supported ends is 10 meters. So the next node point is from the starting point to next point, enter the distance as 10 in X place, then click on enter. So automatically the second node point is also created. This is the first one and this is second one. So the distance between these two node points is 10 meters. Now have to add these 2 points with the help of add beam option. For that, go to geometry, then in beam panel that add beam option will be there. So just select that add beam option, then select this first node point and second node point. This is the beam in between the two node points. So this is the normal simply supported beam in geometry condition. Now coming to the next step in the analytical modeling, properties. In properties, have to give the dimensions of that particular structure. For that beam, have to assign the properties, means the width and depth of the beam. For that, in the right side, go to define option. Click on this define. Now the new tab will be open here. In this, select the beam is in the shape of rectangle. So select this property, shape is rectangle, and now here you can see this is rectangle and the YD and ZD. So here depth and width. So here I'm giving the 0.3 is YD and 0.25 is ZD. And the material is, I'm selecting here the material as concrete material. Then click on add. Then click on close. Now here the property is created, not assigned. So how to assign that property to that beam is, select that material property. Then here the assignment methods are available at the right side bottom. So in these four options, I'm assigning this property to the total beam. So just click on the assign to view, then click on assign, click on yes. So the property of first beam is assigned to the structure. Now this is about the properties. Coming to the next step is materials. In properties, already we have selected that material is concrete. If you have to change any properties of material of concrete, then click on this concrete and click on edit. And here if you want to change any yield stress or tensile strength or compressive strength of the concrete, then change the value here and click on OK. Click on OK. Now just click on assign to view, assign yes. That changed material properties is also assigned to that structure, and there is no need to change about the specifications. Next, coming to the supports. So already we know that the for a simply supported beam in practical condition is not more suitable beam, but in generally for a simply supported beam we are studied about one end is hinge support and one end is roller support. So in the support, you have to create these two support. One end is hinge and other end is roller. So for that, first go to create. In this, the new window will be open here. In this, there are different types of supports are available directly. In that, the pinned support or hinge support both are same. So select this pinned one, click on add. Now again one more support is roller support. So for that, click on create and select this fixed butt. Roller support is not directly available. So select that fixed support, and the roller support is horizontal. If we provide the horizontal rollers, then the reaction will be in vertical direction. So have to remove this F5, release this F5 and select all the remaining. Select all the remaining. Then click on add. So this type of support is considered as a roller support, and the pinned support is directly available. Now select the pinned support and assign that support to one end, and select the roller support and assign to that support to the another end point. So now I'm selecting this support 2, and here I'm selecting this last either side of the node. Then click on the assign to selected nodes. Click on assign. Click on yes. Now coming to the support 3. This is roller support, and select the another end point. Then assign to selected nodes, assign and yes. So these two are end points of our simply supported beam. After this, the support part is also over. Now coming to the next step is loading. In loading, here I told you in the beginning of the session, here I am analyzing the simply supported beam with point load of 10 kilonewton. So in beams there are two different types of loads in generally. One is dead load and one is a live load. So for that, in loading, first go to load cases and details, then click on add. So in this window, first number 1 type of load is, I'm selecting that as dead load, and in the title also have to change that as dead load. Then click on add. Automatically the dead load is added, and here the number 1 to number 2 means the change will be there. So number 2 is, I'm selecting live load, and in this title I'm selecting this as live load. Click on add, then close. Now the dead load and live load are created, but there is no loads in that. So you have to create that loads. Now coming to the dead load is nothing but the self weight of the structure. So select the dead load and click on add. In this, the self weight load is available. So select that self weight load, and that self weight is acting, that load is acting in y direction. So select that as y and that as downwards. So minus. So minus 1. Click on add and close. This is the dead load of the beam. Now coming to the live load, then click on this live load, click on add. In this, the beam is generally called as a member. So on the left side, there are different types of loads: self weight, nodal load, member load, physical member load. All are different types of floor loads, plate loads. All are available. Temperature, seismic, like that. In this, the beam is called as member. So I'm selecting this as member load. In this member load, again there are different types of loads are acting on the beam, just like a UDL, UVL, and point load, trapezoidal loads, like that. So I'm applying a point load. Point load is nothing but concentrated load. So concentrated load, or also called as concentrated force. Select that concentrated force. Here I am applying a load of 10 kilonewtons downward direction. So here I have to put the negative sign for downward direction. So minus 10 kilonewton. And at the center of the beam. So already we have created the beam at a distance of 10 meters span. So the center of the distance means 5 meters. So at a D1 place, you have to put the distance as 5 meters. Then exactly the load is acting on mid span. Then click on add, click on close. Now here all the loads are created, but that load is not assigned to the beam. Now the next step is you have to assign these loads to the beam. So first consider the self weight. Self weight is assigned to view. Click on assign. Yes. Now the self weight is assigned. Coming to the live load, here you have to select this concentrated force and also click on assign to view. Here only one beam, so here I am selecting that as assign to view. Click on yes. Now here you can see the load is displayed on the beam exactly at the mid span. Now up to this is the loading part. Now coming to the next step, analysis. In analysis, at the right side, the option define commands will be there. So first you have to select the define commands. Then in this analysis, these are the print commands. Means the load data, statistics check, and also the total performance analysis. This is. So here you have to select all. Then click on add. Then click on close. Now coming to the top portion. Here pre-analysis commands and post-analysis commands. The pre-analysis commands, then again click on this define commands. In this define commands, this is the information about the material properties and element and problem statistics. So we want all, so click on all, click on add and close. Now similarly, the next step is post-analysis commands. In post-analysis, again click on this define commands. Here, first you have to change the available loads to selected loads. So, by clicking this double arrow, here we are transfer from available loads to selected loads. So, click on the double arrow, then click on add. In this step, in this analysis commands, whatever you want, select all the properties. So, here I want to select the support reactions. Click on add. Member forces. Click on add, and also the analysis results. Click on add and close. Now here the question mark indicates you are not assigned that property to that structure. So you have to assign these two properties. Select that one and click on assign to view. Click on yes. Similarly, assign this one to the beam. Assign to view. Click on yes. So now the next step, all the pre-analysis and post-analysis commands are assigned to the structure. So now the next step is click on run analysis. Then click on save. Here zero errors. If you have any errors in this, you have to rectify that errors. Then only you can see the deflection and shear force and bending moment diagrams of this beam. So here zero error, so click on done. Then for shear force and bending moment diagrams, just select this post processing. In workflow, select the post processing. In post processing, click on the post processing, then this new window will be open, then click on OK here. Now this is the post processing flow. Here you can see on the screen the beam having displacement. So here this green color indicates the displacement curve or elastic curve. Now this is not visible scale. So for that you have to change the dimensions in scale. For that, go to scale here, then select the apply immediately. Here you can change. Here there are two scales. One is load scale, one is result scales. Now we are checking in results. So select the result scales. In result scales, displacement. You have to decrease the displacement of value of this. Then you can see this elastic curve. Click on OK. Now similarly, select this Fy. F is nothing but shear force on Y axis and M is nothing but bending moment. So now I'm selecting the shear force on Y and also the bending moment on Z. So by using this scale, you can also change the select the apply immediately, and in result scale decrease the bending moment in Z direction, then we'll get the bending moment. Here decrease the value automatically. You can observe here this is the bending moment of the simply supported with beam, and also the shear force in Y direction. So the shear force in Y direction is like this. We know that the shear force of a simply supported beam with point load is rectangle and the bending moment diagram is a triangle. Now here you can observe those dimensions also and click on OK. If you here will get the diagrams but not the reaction values and the shear force values and bending moment and also deflection values. Further, here in configurations, in results, in configuration scale, then click on the annotate. In this annotate, select the beam results. In this annotate, here select the beam results. In this beam results, if in case if you want the maximum bending moment value, then select the maximum bending moment and shear force at the end points, and also I'm selecting the maximum displacement value. So I'm selecting all these three and just click on the annotate. Here you can observe automatically all the reactions, not the reactions here. These are the shear force values and shear force. And this is the maximum deflection value and this is maximum bending moment value. Here minus 25 is maximum bending moment and 5 kilonewton is shear force at the end points, and this 0.017 meters is the deflection of the simply supported beam with point load. So these are the results. And also if you want to detailing of the beam, means if you want to check the exact what are the properties and what are the results in this, then go to analytical modeling again. But before that, here in this post processing, all these results are in displacement, and if you want to check the reactions, then select the reactions. Or here you can observe Ra is 5 kilonewton and Rb is also 5 kilonewton. Okay, so like this, these are the displacements. Now I'm going to analytical modeling. Here in the analytical modeling, just double click on the beam, one new window will be open. In this you can see the total detailing of the beam here. So this is the beam dimensions. Here already we entered this depth is 0.3 and width is 0.25 and length of the beam is 10 meters. So here you can see the coordinates also. And in properties, the properties, yes, this is 0.3 and this is 0.25 already assigned. And the material properties, the material is concrete material and the concrete elasticity, concrete Poisson's ratio, density, all are available. And coming to the loading, here this is dead load, and coming to the select the live load, then this is the live load we are given in that. And this is the shear bending values and this is deflection value. So this is the detailing of a simply supported beam with point load at the midspan. In next session, we'll see the another beam with different loads. Thank you.